Okay, we're live. So we're going to look at a couple more patterns today, straight up from the tables. The new thing that I want to do is start trying to connect these patterns to their graphs. My class seemed pretty proficient with just figuring out the patterns, so let's do that first. So we've got three different functions, f, g, and h, and I want to write down the equation for each one, or the rule for the function for each one. Okay, so can you guys help me out on function f? What is happening in function f? What is the pattern?
It's decreasing by 3.
Looks like it's going down by 3. Very nice. Yeah, so it's going down by 3, the y values. X values are just going up one at a time, right? So that should be pretty simple. So what would we write down the pattern is? Let's write that though. -3, -3, -3. So then the pattern, f of x, is another way to write y. You guys have been writing y equals. Well, y is f of x, right? Because that's what comes out of a function when you put an x in. So part of that's going to be what?
Wait, what?
Help me write it down, because we were able to do it yesterday. So where's this go in here? -3 x. Very nice. And now I've just got to find the starting spot. You guys seemed pretty okay at finding the starting spot. So should I add something to that? Should I subtract something to that? We can mess around with it, right? Any ideas?
Add something to it until I start at 0, so
I think you do want to add something.
we'll add 3.
So remember, you can play around with this, but you've got to be able to find the pattern. So the easiest way is to go to the 0 spot and add 1. Let's check that and see if it works. So let's see, if we plug in 3, we're supposed to get -8. Let's see if that happens. So a little test down here is that f of 3 is supposed to be -8. Let's see if I put 3 in there. That's -9 plus 1, -8. Looking good. So you can always look at the 0 term to figure that out. That's kind of the clever way to do it. If you're not sure though, you can just start guessing, putting plus or minus here, trying to look at your numbers and just try to make it work. That's the other way to do it, right? Okay, so there we go. Let's leave that in. +1. Okay, so next guy, let's do it in green. So what is the pattern for function g?
+4. We're
Adding 4?
4 every time.
You guys see adding
Yeah.
4, or 2 to 6 is 4, 6 to 10 is 4. Okay, I think +4, so where's that going to be in here though?
+4x.
4x.
Oh,
4x.
yeah.
You could go +4x, that's fine. That's fine, right? You don't have to put the x part first, it's okay. But I think you need one other thing, because if we try right now and we plug in like 3, well, we don't have 3 in here. How about we plug in -2? If I plug in -2, I get -8, right? Am I supposed to get -8 for -2? Clearly not. I need to add something pretty big, I think. +22. So this one was nice because it had the 0 spot in the table again. What if your table or the pattern that you're working with doesn't have the 0 spot? Find out the 0 spot. That's the easiest way to do it. There's other ways to do it as well, but for right now I think that'll really pay off for you. Okay, so we've got that one. We're going to graph these guys in a second. Let's look at h of x.
It's add 2,
So this guy's going to be what?
h of x equals 2x.
So we're adding 2 each time?
Yeah.
So 2x?
Plus 9. Yeah, 9.
9. Where are they getting 9 from?
You're finding the 0
I
spot.
think they're counting
So-
backwards. 1 would be 11 and 0 would be 9. I agree. Let's check it just to make sure. We plug in 8, we're supposed to get 25. So let's plug in 8. 2 times 8 is 16 plus 9. 25. Check. It's looking good, right? If you're really unsure, you might want to check a couple of them. Let me get this out of the way. Okay, so what I want to do now is graph just a couple of these guys, maybe all 3 of them. We'll see how we do. So let's graph f first. Let's just graph f over here. So the blue one's going to go over here. So let's just plot some points. This should be easy enough, right? -2, 7. Right there. and negative 1, 4, right there, and 0, 1, and 1, negative 2, and 2, negative 5. I think that's enough points to see the pattern. What kind of pattern is that? It's a straight line, right? So besides the fact that that's a straight line, I want you to look at this, the numbers in the equation for the function, and look at the picture up here and tell me where those numbers appear on the picture, because that's what's really important here. That's what we've really been building up to. So where is 1 on that picture?
Right there.
Yeah, I can see you guys pointing to it. What is that? It's where it crosses the y-axis. In other words, that's the y-intercept. Now, figuring out where the negative 3 is on here, I think, is a little bit tougher, but I'm gonna give you a little help with that. Where's the negative 3 on here? I guess I should use purple, since purple's not one of our line colors. So I think it's like this. Look at these couple of points. If you draw a little triangle, like from there to there, or from there to there, or any 2 points next to each other, how long is this part? Look at my fingers carefully. 1, 2, 3. There's 3 in there. And it's going down, right? How far is this part? Just 1. Let's look at another one before we see if we can make a leap of faith. So G. So now I'm going to graph this guy. So we've got negative 5, 2. So let's see, 1, 2. Now I think I'm going to graph G on this other one. Negative 5, 2. Right there. And the negative 4 is at 6. Right there. And negative 3 is at 10. And then we'll graph one more point. Negative 2 is at 14. Well, we'll keep going. So that's 10, 11, 12, 13, 14. And 0 is at 22, 15, 16, 17, 18, 19, 20. Let's see. So negative 2 is at 14, negative 1 is at 18, 15, 16. 17, 18, and then up here. So mine looks a little bent, but it's supposed to be straight. So here we go. There's our not quite straight line. I think you guys get the point. So now go back and look at the numbers here. Where's 22? Way up there. It's again the spot where it crossed. It's the y-intercept. And 4, where's 4? How far is that? A little hard to see from my scale, but it's supposed to be 4. So, put this over 1, because 4 is 4 over 1, right? Negative 3 is negative 3 over that 1. And I hope you guys can see what's happening here already. So if you're watching the video, I'd pause it now and go ahead and graph h of x and see if it displays that same relationship with the 2 different numbers. This guy we're going to be talking about is the slope of a line, and this guy is the y-intercept. And that shouldn't be coming from mysterious places. It comes from, how do you get from one point to another? You use the slope. Where do you start from? You start from wherever it crosses the y-axis. This all goes back to the patterns we've been working with. So I'll see you next time. Okay, so I guess I lied. I'm back sooner than expected. So we're going to look at the graph for this last one. I don't know if my graph is big enough here. We might have to expand it a little bit, right? Make it a little taller. So let's make it a little bit taller. So we need to go up to like 25, right? So let's say this is 10. That's about 20 then. That's about 30. Starting at 2 through 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So for this guy, you should have had a point at 213. I'm just going to kind of eyeball this one about right there. And then at 315, about right there. And then at 4, oh man. Need to make my graph a little bit better. There we go. 315, 417, about here. 519, about there. I think I need to make the scale a little bigger. This is the problem with eyeballing graphs. So that was 19, so we'll say this is 20. And we'll say this is 30. It's not perfect. So 621 is going to be like there. 723 is going to be like there. 825 is going to be like there. So there's your line. Yeah.
Why would you connect it all the way through the y-axis?
Good question. Are these all the points that exist on that line?
No.
They're just like a bunch of stuff that said random person gave us.
That's just one section of the.
We could keep plugging in other stuff and get values up here. Or we could plug in negative numbers and get values down here. So very good question. The question is, where does the numbers that we came up with for our function pattern, our equation, where do those show up? Here. 9 is supposed to be the what? 9 is supposed to be the y-intercept, the 0 spot. Does it look like? Does it look like mine could be 9? I mean, it's not perfect, but it could be, right? Like that's because my line is not perfectly straight because I'm like not an artist. You know what I mean? So could this be 9? I think the answer is yes. And now what you're going to want to start doing is thinking about the slope. Does this line have a positive slope? In other words, left to right, is it going up? Yes, and it's supposed to because 2 is positive. If this was a negative number attached to the x, like -3, then it'd have to be going down from left to right. And the bigger this number is, you're going to find out, the steeper it's going to be, because when you look at an individual triangle between here, when it's 2/1, that's so steep. If this was 3x, this triangle will go up higher, right? So it'd be steeper. If it was 4x, this triangle will go up even higher, that'd be even steeper. If it was 1/2 x, then it'd be a much flatter triangle. So that's what you guys are going to be working with as we continue with patterns.